All right, part A. If you're supposed to estimate a derivative, so notice the table we have above is h, and we're trying to essentially estimate h's slope at 6. The best way to estimate h's slope at 6 is to find out the kind of closest in-between slope that involves 6. What I mean by that is the values that are closest to 6 are 5 and 7, and so we're going to do the slope formula with the x values 5 and 7 and the y values associated with them. All right, and so when we do that, 11 minus 6 is 5, and 7 minus 5 is 2. So what we're going to say is h prime of 6 is approximately 2.5, and it says use correct units. And so this is, h of t is talking in meters, t is years, so we're going to say 2.5 meters per year. All right, and they also want us to interpret it. Now I'm just going to verbally say the interpretation instead of writing it, but what this means is after 6 years, or at 6 years, the height of a tree is increasing at a rate of approximately 2.5 meters per year. That would be your correct interpretation. Again, you want to write that out, but kind of that wording, and the key there is saying at year 6, not saying, or you could also say after 6 years, but not like, just be careful that you don't say something possibly incorrect with that 6 years. Anyways, and then obviously it's 2.5 meters per year. All right. Let's see here. Part B. Explain why there must be at least one time from 2 to 10 that h prime of t equals 2. All right. Now the idea is if you're looking for a guarantee that the derivative has to be some value, to me that sounds like the mean value theorem. So what does the mean value theorem say? Well, it says if you have a differentiable and continuous function, the average rate of change, in other words what we did in part A, which isn't exactly 2, but maybe somewhere else it is equal to the instantaneous rate of change, or in other words, the derivative. So what we need to first do is show, since h of t is differentiable, it is also continuous. That's definitely a big condition of the mean value theorem. It is, your function is differentiable and continuous. From there, you want to say maybe observe, and it took a little bit to find, but if you look at the years 3 and 5, I'm going to write it like this. H of 5 minus h of 3, for some reason I was thinking 6, I guess that's because that's what h of 5 is, whatever. Anyways, minus 3. If you notice, this is equal to 2. All right, so since h of t is differentiable and continuous, and because of this, therefore, there must be, I'm going to write it like this, at least one t between 2 and 10, or 3 and 5 specifically, where h prime of t equals 2. In other words, we've satisfied the conditions of the mean value theorem. We've shown that it's differentiable and continuous, and that somewhere between 2 and 10 there is a slope, a secant slope that we can find from the table that is equal to 2. So the mean value theorem says there's going to be exactly a derivative that's equal to 2 as well. They didn't ask us to solve for it, we just need to say that it is possible. All right, up next, part C. Now, part C is important because you will practice your trapezoid rule. However, you're definitely not going to see this exact question on this year's exam, and that's because they say approximate the average height of a tree. So let's see what happens here. What we can do is we can definitely approximate what's going on, or the change that's happening from 2 to 10. So let's do that at least. Let's get the trapezoid right. So what we can do is we can say that the integral of h of t from 2 to 10 dt, make sure you include the dt, is going to be approximately, and now we're going to use our trapezoid rule. And notice this time when you look at the x values, or really the t values, they are not consistent, so you really do have to do the trapezoid rule every single time. So we're going to have 1/2 times the change in x times the average heights. So we have first 1.5 plus 2. That's our first trapezoid. Our next is 1/2 times the change in t, which is 2, times the heights added together. Next, again, we have the 1/2 times the change in x from 5 to 7 is 2 again. Now we're going from 6 to 11. And last but not least, this time we're changing by 3, and we're going from 11 to 15. Now, if you work all this out, and again, this is a non-calculator question, so some of this does get a little bit tricky. I guess I'll work through this. This is 3.5, which don't forget is 7 over 2. So this is really times 1 times 1/2 will be 7 over 4. Our next trapezoid is going to be 1 times 8. Our next trapezoid is going to be 1 times 17. And our next trapezoid is going to be, let's see here, this inside is 26, so 13 times 3, which is 39. All right, let's see here. 8 plus 17 is 25. 25 plus 39 is 64. And now I have another 1 in 1.75, so 64. We have 65.75 is what that is. Now the idea is the average value of height, or in other words, the average height, or the average value of a function, height is a function, is given by 1 divided by the difference in the bounds of the function, so 10 minus 2, times the value of the integral of the function. Now this is the part that you aren't required to know this here. You definitely need to know how to get the 65.75, but you don't need to know this average value of a function. This is part of the last unit that they cut off. So essentially, I'm just going to call this, I'm going to say, I guess it's approximately 1 divided by 8 times 65.75. Remember, you don't technically have to simplify everything in the AP exam. You just have to show the correct math. All right, and especially since this is non-calculator and that's getting messy, and since I guess I thought I was going to finish faster than I did, but especially if you're in a time crunch, at least write this down and move on, and maybe if you have more time, then try to go back and make this nicer. Again, also, even though this is non-calculator, everything you do this year, you'll be able to use a calculator, so I'm going to move on, but hopefully you kind of see what I'm getting at there. Up next, part D. Okay. So let's see here. It says when the tree is 50 meters tall, essentially we have another function g that models the height, but it's based on the diameter of the tree. So they want to know when the tree is 15 meters tall. They also tell us the diameter of the tree is increasing at a particular rate. According to that model, what is the change in height at the time when the tree is 50 meters tall? Okay, so essentially they want to know g prime of x when essentially g of t is 50. Well, one thing we can do right there is let's figure out when g of t is 50, when g of t equals 50. Now, what this means is we need to find when 100x over 1 plus x equals 50. When you multiply that denominator, you get 100x equals 50 plus 50x. And then eventually you're just going to see that x equals 1. So now we know what x equals. And then also the other piece of information is saying dx dt equals positive 0.03. All right, so we know dx dt, we know x. Now it's time to find g prime of x. And g prime of x is going to be a quotient rule. So we'll bring the bottom to the top, multiply by the bottom derived, and notice we're going to need a dx dt when we derive the top derived. So bottom minus top derived minus bottom times top derived, goodness, minus, and then now we're going to derive the bottom, which is just 1 dx dt times the original top all over the bottom squared. And the idea is now we definitely know that x is 1 and dx dt is 0.03, so what we really have here is 2 times 100 times 0.03 minus 0.03 times 100 all over 2 squared. And that's just 2 times 3, which is 6, minus 3 over 4. And so we get 3 over 4. You see here. And yeah, that's just about it. The big thing here is that they definitely want to see the chain rule taking place, which technically I did not do. Realize that when you're deriving with respect to t, essentially you are deriving g of x with respect to x, but when you're deriving with respect to x, you're technically deriving by dx dt. Maybe I did that by getting the right answer here by having the dx dt's, but I definitely didn't use their exact format, so definitely just be careful about that as you work through the problem.